So, have you ever stopped to wonder what's actually powering, well, pretty much everything? I mean, the internet, your Android phone, that smart TV on your wall, and those giant cloud servers that deliver your movies. What's the secret sauce? Well, today we're taking a guided tour of the engine behind it all, the Linux universe. Let's dive in.
All right, here's the plan for our trip. We're going to start with the why, why Linux even matters. Then we'll pop the hood and see how the OS is put together. After that, it's time to get our hands dirty with the command line, learn the rules of the road for security, and then we'll send you off on your very own Linux journey. First stop, let's get right to the heart of it. What exactly is Linux, and how did this project, with its little penguin mascot, become one of the most important pieces of software on the entire planet? To get a sense of its sheer scale, just think about your day. The phone in your hand, the websites you're browsing, the cloud services you use without even thinking about it. What's the one thing they all have in common? Yep, the answer is Linux. It's this quiet, incredibly powerful engine that's just running in the background of almost everything we do digitally. It's the ultimate unsung hero of modern technology, and most of the time, you never even know it's there.
Now, what makes Linux so different is its DNA, its core philosophy. It's all built around something called the GNU General Public License, or the GPL. And this isn't just some boring legal document, it's a revolutionary idea. It guarantees that the software is free. Free for anyone to run, to study, to change, and to share. It's software literally built on freedom.
And that freedom is precisely why Linux is everywhere. The entire Android operating system, its foundation is the Linux kernel. The whole cloud computing industry, it basically runs on Linux. And it's not just for giant companies. You can run incredible free software right on your own Linux desktop, from photo editors that rival Photoshop to full-blown Office suites. Okay, so how does this whole thing actually work? For our next stop on the tour, we're going to go under the hood and see what the Linux operating system is really made of. Here's the single biggest difference between Linux and something like Windows or Mac OS. Linux is modular. Think of it like a set of Legos. The core engine, the kernel, the system tools, and the visual interface are all separate blocks. You can swap them in and out to build exactly the system you want. Windows and Mac, they're more like a pre-built model. What you see is what you get.
And you really see that modularity when it comes to the look and feel, what we call desktop environments. You have so many choices. You could go for the slick, modern feel of GNOME, or maybe the super lightweight and fast XFCE. You get to pick the exact style that fits you best.
Now let's talk organization. In Linux, every single file and folder lives in one giant unified tree. And every branch on that tree starts from one single spot, the root directory, which is just represented by a single /. Simple, right?
And from that root, the whole system branches out into these standard, predictable folders. This is so cool because it means on pretty much any Linux system in the world, you know exactly where to find things. Need to change a setting? Head to /etc. Trying to figure out a problem? Check the logs in /var log. It's a beautifully logical system.
All right, time for our next stop, the real power center of the whole operation. This is where you stop clicking and start talking directly to the system. Welcome to the command line.
Instead of poking around in folders with your mouse, the command line lets you just ask for what you want. So let's say you want to see absolutely everything in the folder you're in, even the hidden stuff. How would you ask for that? It's as simple as this, LSA. The ls command is short for list, and that little a is a flag, an option you give the command. In this case, a just means all. So you're literally just telling the computer, list all files. But here's where the magic really starts. It's not just about running one command at a time, it's about chaining them together. You can run a command like date and instantly capture its output and save it in a variable. This might seem small, but it's the first step to automation. You could write a script that makes a backup of a file and automatically adds today's date to the file name. And it all starts with this simple concept. Think of these commands as your starter toolkit, your Swiss Army knife. With just these few tools, you can do almost anything. MV moves files, CP copies them, grep lets you search for text inside files, tar bundles them up, and SSH lets you securely log into another computer anywhere in the world. So powerful. So, now that we know how to get around and how to use the tools, let's talk about the rules of the road. Our next stop is all about users, permissions, and keeping the system secure. On a Linux system, every user account is listed in a central file, etc/password.
But here's the clever part. When you need to do something with admin powers, you don't actually log in as the all-powerful root user. Instead, you use a special command, sudo. It lets you borrow those powers for just a single command. It's a way safer way to manage things.
Now let's talk about how Linux decides who can do what with a file. It uses this really brilliant but simple numeric code. Just remember 3 numbers. 4 means read, 2 means write, and 1 means execute. You just add them up. So you want someone to be able to read, write, and execute? Okay, 4 plus 2 plus 1 equals 7. Just read and write. 4 plus 2 is 6. It's that easy.
And you see this code in action with 3 digits. The first number is for the file's owner, the second is for the users group, and the last one is for everybody else. So a super common permission you'll see is 644. What's that mean? Well, the owner gets a 6, that's read and write. The group and everyone else both get a 4, read only. It's an incredibly smart and compact way to control access.
Finally, let's clear up something that trips people up: links. A symbolic link is easy. It's just a shortcut like you have on your desktop. If you delete the real file, the shortcut breaks. But a hard link? That's different. It's more like giving the exact same file a second name. It points to the same physical data, so even if you delete the original file name, the data is still there, safe and sound, accessible through the hard link.
Well, our tour is just about over. For our last stop, let's swing by the gift shop and pick up the key souvenirs, the things you'll want to remember as you start your own journey with Linux.
So here it is, your cheat sheet for going forward. Really work on getting those essential commands into your muscle memory. Get a feel for the file system so you instinctively know where things live. Play around with some basic scripts to see how powerful automation is. And never forget those 2 big ideas: the incredible flexibility of modular design and the philosophy of freedom that started it all.
And with that, our tour is complete. We've seen the big picture, we've looked under the hood, and we've learned the basic language. So now there's really only one question left, and it's the most exciting one of all. What will you build with it? Thanks for coming along.